Assalamu alaikum students. After we have finished properties of scalar product or dot product, now we got aware that once we were having two vectors which are perpendicular to each other, then their dot product vanishes. And if we are having two vectors which are parallel to each other, or what I mean is equal to each other, then their dot product or scalar product is equal to the square of the magnitude of one of the vector. Now today's our topic is dot product of two vectors in terms of their components. How we are gonna calculate? Let we are having two vectors. Let vector A equals to what? Axi plus Ayj plus Az of k. This one vector, and we are having another vector. This vector A, and Ax is its component along x-axis, Ay its component along y-axis, Az it is along z-axis. And similarly, we are having another vector, that bxi plus byj and bzk are their components. Now we have to find out their dot. Now a dot b, a dot of b equals to, first we are going to write down whole a. What is a? That's a xi plus a y of j plus a z of k dot of, now we are having dot b, it is bxi plus byj plus bz of k. Now we have to make the dot product of two vectors. So what for that very purpose, I will write it like this. Now a, I have to make dot of, listen, this is the magnitude and this shows the vector. This is the magnitude, this shows vector. So I will put it like this: ax bx. Now vector there is I, and here the vector is I, and among them we are having dot. I will put it I dot I. Because dot product are in the coming lectures, we have to write about cross. That's among the vectors, not among the magnitudes. Ax magnitude, I is the vector along with. I shows that this whole axis, for example, this will be 3i. 3 is the magnitude, and it shows it is along the x-axis. So ax bx I dot I. Now this ax is having a dot with this very term, plus I will put it like this. Now ax by, now what we are having, vector I dot of vector j. Proceeding this was I ax, then it will be bz. Now it will be simply I dot of k. Now these were the multiples of ax I with bx by bz. Now we're having, now we'll have ay, it's going to multiply with bx, and we're having a vector. Now we'll put what is first, j dot of I. If we put I dot j, that hardly matters because it's a scalar product. Then we'll put plus, and we'll be having ay by. Now it will come ay, we're having j, by we're having j dot j. Now plus ay bz. For ay we're having j, for z we're having k, j dot k. Why I am putting only dot here and why not here? Because the dot or crosses among vectors. J and k are vectors. Az, bz, ay, by, these are not vectors. These are the magnitudes. Plus Now it will be az bx. Now it will be k dot I plus az by. It will be k dot of j, and it will be plus az bz. It will be k dot of k. So among all those three terms, now what we'll get finally, a dot of b equals to, now I dot I. Lastly, we have read about when we are having two equal vectors, then their dot product is equal to the square of magnitude of one of the vector. So it will be ax bx, and now I dot I, that comes out to be 1. Why 1? Because lastly we have read once we are having two vectors. If we'll put it here, I dot of I, that is 1 into 1 cos of 0. Cos 0 is 1, so simply it is 1. So this very term becomes as 1. We're having this very term, this will become as j dot j, it will be j dot I, this very j dot j, this will become as 1, and we're having k dot k, this will become, and these very terms exist. Listen carefully, this very term vanishes. Why it's going to become 0? Because I and j, they are having an angle of 90. I will place ax, I will write ax by, but once I have to, what I will write instead of I dot j, instead of I dot j, I will write 0, because it will be 1 into 1 cos of 90, cos 90 is 0. Here I am going to write ax bx I dot I, that's 1. This term vanishes, this term vanishes, then this j dot I, this term also vanishes, this term vanishes, this term vanishes, this term vanishes, and this term vanishes. We are left with only three terms. What? Ax bx plus ay by plus az bz. This is what we have to remember once we have to make the dot product. Once we have to make the dot product of two vectors, then that is simply the multiply of the components, the same components. The components along x-axis, we have to multiply them. The components are plus the components along y-axis, we have to multiply them, plus we have to multiply the components along the z-axis. This is how we are going to calculate what I mean to say dot product of two vectors. For example, if you are having a simple question, find dot product dot product if vector a equals 2I, you can place plus 3j minus 2k, and vector b equals to I, one side, then the component here is 1I plus 2j plus 2k. So now I will here right now a dot b equals to what? It is 2I plus 3j minus 2k dot of, here I have to use the dot of I plus 2j plus 2k, and finally 2 is multi going to this, it will be 2 into 1 plus 3 into 2 minus 2 into 2. So how much it is, which implies a dot b equals to 2 into 1, that's 2, 3 into 2, that's 6, 6 plus 2, that's 8, 8 minus 4, it will be simply 4, a number. A dot b is equal to 4. So this is how we are gonna make the dot product of two vectors. Tomorrow we'll be with couple of more questions regarding the topic. Till then, Allah Hafiz.